Here we're asked to solve the logarithmic equation log base 6 of x plus 8 plus log base 6 of x minus 8 is equal to 2. So we have a log equation that we're starting with because it has logs. We know to solve a log equation, we have to rewrite it as an exponential with the same base. However, the problem is when we have a log equal to a number, we can rewrite it as an exponential. And that's not what we have here. Here we have a log plus a log equal to a number. So we're going to have to condense those two logs down into a single log so that we have a log equal to a number, which we can then rewrite as an exponential and solve. So in order to condense those down, notice we've got a log plus a log, and they have the same base. So we can use our product rule. And so we can rewrite that as the product of the logs. And so log base 6 of x plus 8 times x minus 8 is equal to 2. So now that we've used our product rule and we've condensed that to a single log, we can rewrite that log as an exponential in order to be able to solve it. Remember, when we rewrite it as an exponential, we keep the base the same. So our exponential is going to have a base of 6. And then we switch our input and our output. So instead of this being the input, it's what's going to be the output now. And instead of 2 being the output, it's going to be the input. So the 2 becomes the exponent. We're raising it to the second power. And our x plus 8 times x minus 8 becomes our output. It's going to be what it's equal to. So now we've rewritten it as an exponential, and we can see that as an exponential, we've got 6 to the second power. We know that 6 to the second power is 6 times 6, which is 36. So we have 36 is equal to x plus 8 times x minus 8, which we know how to solve. Turns out this one's going to be a quadratic when we multiply on the right. And so remember, when we're multiplying here, we're going to have to distribute twice or FOIL. And so we end up with x squared. We end up with a minus 8x and a plus 8x, which gives us 0 x's when we combine them, and then a minus 64 when we multiply there. Now that we've got a quadratic, we know we can solve that either by factoring or the square root property or the quadratic formula. All three will actually work in this case. You can set it equal to 0 and then factor it. You can use the square root property because it doesn't have that middle bx term. And you can use the quadratic formula. You'll just have a 0 for your b. So in this case, I think it's probably going to be easiest to use the square root property since we don't have that middle term. So getting the x squared by itself, I'm going to add 64 to both sides to get 100 is equal to x squared. And then take the square root of both sides. Again, remembering when we take a square root, we get a positive and a negative. We get a plus and minus 10 because 10 squared is 100 and negative 10 squared is also 100. So we have two possible answers for x. It could either be positive 10 or negative 10. It's always a good idea to go back and check those because we know that the domain of the log is 0 to positive infinity, not including the 0. We cannot take the log of 0. We cannot take the log of a negative number. And so when we plug in 10 here, we're taking the log of 18, which is a positive. When we plug in 10 here, we're taking the log of 2, which is again a positive. So 10 should work. You can check it by simplifying, and it does work. Notice when we plug in a negative 10, when we plug in negative 10 here, we're taking the log of negative 2. Can't take the log of a negative number. Same thing here. When we plug in negative 10, we're taking the log of negative 18. And again, we cannot take the log of a negative number. That means the negative value does not work, and our only answer is positive 10 in this case.